If you asked right now how long it would take us to reach Mars, the answer might sound simple. But the truth is that nothing about traveling to the red planet is as straightforward as it seems. The distance between Earth and Mars is constantly changing. The route we follow isn't a straight line, and rocket speed is far from the only factor that determines this journey. Today, you'll understand exactly why this trip takes so long, and what the real time is for a mission to reach Earth's most famous neighbor. To start, we need to make something clear. Mars isn't sitting still, waiting for humanity to arrive. Both Earth and Mars orbit the Sun, but they do so at different speeds. Earth moves faster, completing a lap in 365 days. Mars, farther out and slower, takes about 687 days to complete the same path. That means that throughout the year, the two planets are either moving apart or drawing closer the whole time. So there isn't a single fixed distance between them. When the two planets are on opposite sides of the Sun, the separation can exceed 400 million kilometers. But when they're roughly aligned on the same side, that distance drops to around 54 million kilometers. The variation is so large that, depending on the moment, Mars can be almost 8 times farther away, and that already answers part of the question. There is no fixed time to get to Mars, because the distance is always changing. But even knowing that, another doubt remains. If the minimum distance is 54 million km, why don't we choose the moment of closest approach and simply go in a straight line? It would be quick, simple, and completely impossible. When you launch a spacecraft, it doesn't go to the destination like a plane flying to another city. Instead, it moves around the Sun just like the planets. That's why we don't point the rocket directly at Mars. If we did that, by the time the spacecraft reached the point where the planet was, Mars would already have moved, and the probe would simply arrive at empty space. So, how do we do it? We use something engineers call a Hohmann transfer, the most efficient route to go from Earth's orbit to Mars's orbit. It works like this. Instead of chasing Mars, you launch the spacecraft toward a point in space where Mars will be in the future. It's like hitting someone who's running by, aiming at the spot where they will be in a few seconds, not where they are now. The difference here is that we're talking about entire planets and distances of hundreds of millions of kilometers. The Hohmann transfer is a half-ellipse trajectory. The spacecraft leaves Earth, enters this elongated orbit around the Sun, and follows it until it intercepts Mars's orbit at the exact moment Mars passes through there. It's like entering a giant oval track that connects two different orbits. And why choose this route? Because it uses less fuel. In space, with our current technology, efficiency isn't optional. It's an absolute necessity. Fuel is heavy, expensive, and very hard to carry. The less you burn, the safer and more feasible the mission becomes. But that efficiency comes at a price: time. The Hohmann transfer is the correct, proven route, but it's also relatively slow. That's why missions to Mars never take a few weeks, but months. To understand this better, it helps to look at the history of missions we've already flown. There have been many. The first attempt to reach the red planet happened back in the 1960 seconds, and since then, dozens of probes have been launched, not all successfully. Mariner 4, for example, launched in 1964, took about 228 days to get there. Mariner 6, in 1969, took 156 days. Decades later, the Mars Global Surveyor, launched in 1996, took about 10 months. And of course, there are more recent missions, like the Mars Science Laboratory. The spacecraft that carried the Curiosity rover launched in 2011. It took about 254 days to reach Mars. The Perseverance rover, which arrived in 2021, traveled for approximately 203 days. All these numbers, although they vary in some cases, have something in common. They all fall within a well-defined range, and that's where we start to approach the real answer. Before that, though, there's another factor that directly affects travel time: the launch window. As strange as it may seem, we can't go to Mars whenever we want. Earth and Mars need to be aligned in a specific way for the Hohmann route to work. This alignment happens roughly every 26 months. In other words, if you miss the window, the next chance won't come for a little over 2 years. That moment doesn't guarantee that Mars is at the minimum distance of 54 million km. It only guarantees that Mars will be in the right position in its orbit for the spacecraft to meet it in the future. The route is calculated so precisely that if you launch the rocket a few days early or a few days late, the spacecraft can end up passing behind Mars or far ahead of it. That's why space agencies treat these dates as sacred. Everything needs to work to the exact minute. With all these variables, the changing distance, the route that isn't direct, the launch window, and the need to save fuel, you can already imagine that travel time isn't just a matter of speed. It's a matter of trajectory, orbital mechanics, and perfect timing. And now, with all that explained, we can get to the main question. How long would it really take to reach Mars with current technology? If you've looked at the pattern of previous missions, you've already noticed there's a pretty solid range between 6 and 9 months. That's it. The vast majority of missions travel for something between 180 and 270 days. On average, we can consider about 7 months as a typical travel time to Mars using chemical rockets and the Hohmann trajectory. And why can't we do it much faster? Because accelerating more would require an absurd amount of fuel. That would make the spacecraft very heavy, very expensive, and very risky. Every time you increase the speed you need to reach, you have to increase the amount of fuel in a disproportionate way. And that creates a domino effect. More fuel means a bigger rocket, which requires even more fuel to lift off the ground, which increases the size even more, and so on. It's a cycle that's not worth it for an interplanetary trip. That's why, even with all the technology of modern rockets, we still use the most efficient route, even if it takes months. Energy is the limiting factor, not pure speed. Another important point is that the distance the spacecraft travels isn't the straight distance between the planets. The Hohmann transfer increases the total path because the spacecraft needs to enter an elongated orbit around the Sunday. Instead of traveling 54 million kilometers, it may end up covering something between 400 and 600 million kilometers, depending on the planet's positions at launch. That explains why the trip takes so long, even when the planets are relatively close. In the end, the correct answer to how long it takes to get to Mars isn't just months. It's the result of a complex orbital dance, a rare window that only appears every 2 years, and a route that prioritizes efficiency over speed. And the conclusion is clear. With current technology, humanity needs approximately 6 to 9 months to go from Earth to Mars. That range is what we've seen historically. It's what space agencies use, and it's what remains the safest and most efficient with modern chemical rockets. Now imagine what it will be like when we manage to reduce that time, not with far-off dreams, but with advanced engineering that's already starting to emerge. The day this trip takes weeks, not months, could mark a new chapter for humanity. If you enjoyed this video and want to follow more content about space, exploration, and the future missions that will change our history, don't forget to subscribe to the channel and leave a like. There's much more on the way, so share it with your friends.